Hey guys, this is Kerry, and this is the answer key video for, I guess it's not really an answer key, it's just the lesson. So here we go. For problem number 1, determine the exact value of sine 330 degrees. So when you see this phrase on the regent's exact value, that means not a decimal. Because frequently when you write a decimal, if you do something like, I don't know, for pi 3.1415 dot dot dot, we would say that this value is not exact because it doesn't include all of the remaining decimal places. So if you write it as a fraction, however, well, for pi you can't write it as a fraction, but for a lot of these, if you write them as a fraction, something like the square root of 3 over 2, even though that decimal would be infinitely long, non-repeating, square root of 3 over 2 captures the entirety of that number without cutting it off anywhere, without rounding it. So when you see this phrase exact value, it means not a decimal, which should make you think it's probably going to be a fraction, but it's not going to be this one. So let's figure out the correct fraction. So for the sine of 330 degrees, let's do it graphically. 330 degrees is going to be, well, let's label these 90 degrees, 180 degrees, 270 degrees, and we start here always. So this would be 300 or 0 degrees, but also if we go all the way back, that'd be a full circle, so 360 degrees. All right, so let's draw our angle. So you start at 0 degrees, 330 goes past 90, past 180, past 270, and almost to 360. And then we've got 330 degrees right here. Okay, so for the exact value of sine 330 degrees, that is too big of an angle to fit in a triangle. So maybe you would think, okay, well, maybe I'll use the coordinate plane definitions. But then unfortunately, these definitions aren't helpful either because we don't know any x, y, or r values, so we have to cross those out. So it looks like what we have to do here is we've got to use our reference angle. So hopefully on the quiz yesterday on Delta Math, you guys got a lot of practice finding reference angles. The reference angle is always the positive acute angle between the terminal side and the x-axis, and it's always acute. So sketching that in, the terminal side, the x-axis, it looks like the acute part of that is this part right here because it's smaller than 90 degrees. So this must be alpha. Now to compute alpha, we can find the exact measurement for this angle using a little bit of critical thinking. Together, 330 degrees and alpha together make a full circle. So because 330 degrees and alpha make a full circle, alpha has to equal 30 degrees, so they combine to make 360 degrees. All right, so now that we know alpha is 30 degrees, we can totally compute the exact value of this. So we know that the sine of 330 degrees is almost the same thing as the sine of the reference angle, 30 degrees. Now where things are different is, well, let's not get to the difference yet. We know that this is almost equal to, if you want to find the sine of 30 degrees, maybe that makes you think of your 30, 60, 90 reference triangle. So 30, 60, 90, 1, 2, square root of 3. So the sine of 30 would be 1 over 2. Now to make these exactly equal, we have to remember that sometimes this big angle will have positives or negative signs. So do all students take calculus? Only cosine is positive here, and so sine needs to be a negative value. All right. Write each of the following trig ratios in terms of their opposite, adjacent, and hypotenuse side lengths. So sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, cut, toa. Cool. Now, we learned last time there are these other trig functions, and these are all reciprocals. So they're called the reciprocal trig functions. And so what a reciprocal means is, right, you flip it. So I always line them up in this order. Sine's reciprocal is cosecant, so I always think about that one first in my mind because I always think about sine first in my mind. Cosecant is the flip of sine, so I'll be flipping this, hypotenuse over opposite. Cosine flipped gives you secant, so that's always hypotenuse over adjacent. And tangent flipped gives you cotangent, so that's adjacent over opposite. Now writing these names, I'm just going to remind you guys of how you write these in their full words. And that will help you to say these names correctly as you talk about them or as you type about them in your questions to me. So cosecant, secant, and cotangent. For those of you thinking about taking calculus next year, this phrasing, cosecant, secant, and cotangent, are really useful, and you'll talk about these functions a lot in calculus. So it's good to have them fully mastered now. Let theta be an angle in the second quadrant. Okay, it seems like a picture is going to be useful for this one. So let theta be an angle in the second quadrant such that the terminal side passes through the point -4, 3. 1, 2, yep, second quadrant, that's correct. So here's theta. Write each of the trigonometric ratios below for the angle theta described in the problem. All right, so because we have an x and a y coordinate for this one, it makes me think about our coordinate plane definitions. And so the coordinate plane definitions are sine is y over r, cosine is x over r, tangent is y over x, and we derive those in lessons 3 and 4. So we have x and y, we do need r. So to find r is the length of this side. That's pretty hard to find, but then you think, oh, well, there's a little triangle here, and because we went back 4 units because of the x coordinate, and up 3 units because of the y coordinate, that's a little mini right triangle. And so we can do a squared plus b squared equals c squared. So a squared plus the length of this side is 4 if we think about it as a triangle. 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. c equals 5. And so we plug in 5 for r. And now we've got everything we need. So sine of theta is y over r, 3 over 5. Cosine of theta is x over r, -4, and make sure you use the -1 from the x coordinate, over 5. Tangent of theta is y over x, so 3 over -4, and that becomes -3 over 4 when we put the negative sign out front. Each one of these is just a reciprocal, and so we're just going to flip the corresponding one. Sine, when you flip it, becomes cosecant, so 5 over 3. Secant is the flip of cosine, so -5 over 4. Put the negative sign out front. Cotangent, when you flip it, is -4 over 3. And we've got all of our reciprocal trig functions, just using the fact that they're reciprocals. So let's do one more thing with reciprocal trig functions. Let's find some exact values without the calculator. So reciprocal trig without a calculator. Guys, put the calculators away. It's time to do some problems that you would think would be really difficult without a calculator, without the calculator. So secant 225. Man, this one's pretty bad. All right, a picture always helps when you have big angles that don't fit in triangles. It even helps with ones that fit in triangles. So for 225 degrees, you have 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Our angle starts where it always starts, and it opens past 90, past 180, but before 270, and here is 225 degrees. Now the important thing to think about with this angle is we can't use SOHCAHTOA because this angle is too large to fit in a right triangle. We can't use our coordinate plane formulas because this angle doesn't have any y and x and r values given to us. So the best approach here is to take the reference angle approach. Which is always going to be written alpha. So that's the first letter of the Greek alphabet, and that's the symbol that we use for reference angles. And the reference angle is always between the terminal side and the x-axis. Well, that's a bad x-axis. And the x-axis. It's also always an acute angle. So it looks like this little piece here is actually alpha. So now, alpha is a little trickier to find this time. It looks like this whole green angle was 225. This top part of it in red, this was 180 degrees. So if we want to get just the alpha piece of it, this blue piece, what we could do is we could do the full green angle, 225 degrees, subtract off the red piece on top, the 180, and that leaves us with our alpha value because that's just the leftover piece right here. So doing the subtraction here, no calculator, let's see, 5 minus 0 is 5, 12 minus 8 is 4, 1 minus 1 is 0, so 45 degrees. 45 degrees, that's one of our really useful values. So we know that secant of 225 degrees must be really close to the secant of 45 degrees. Now, for 45 degrees, I immediately draw the reference triangle. This is going to be the 45, 45, 90. So we'll do 45, 45, 90, 1, 1, root 2. And secant is, oh man, secant, we're always going to remember the order, right? Secant is the middle one, so that's going to be the flip of cosine. So for secant of 45 degrees, we're going to flip cosine of 45 degrees. So cosine of 45 degrees, that would be 1 over root 2. And so when we flip it for secant of 45 degrees, we just get root 2. Flipped, it equals root 2. Okay, so this is root 2 here. So going back here, secant of 225 degrees has to equal square root of 2. But then the last thing to keep in mind here is when we do an all students take calculus, only tangent should be positive here. And that doesn't help us with the secant part of it, because the t here doesn't have a relevance to that. However, if we remember that secant was the flip of cosine, because t is positive here, cosine should have been negative. And if cosine is negative, that will mean that secant 225 should also be negative, because when we flip this negative number, it should stay negative. All right, now that problem was pretty complicated. So let's take a look at problem number 1 down here, which is really problem 2, sorry about that. This one is a little bit tricky. It's got negative 150 degrees. And let's see. Zero degrees. Oh, these are negative, so let's put negative 90 degrees, negative 180 degrees, negative 270 degrees. Because negative angles rotate the opposite direction. And so, let's see, we had here negative 150 is going to be going back past 90. Oops, that's the straight line tool. Back past 90 into this quadrant. So here's negative 150 degrees. Now for negative 150 degrees, the reference angle is going to be here. And you would think, well, that seems like it should be negative 30, but reference angles are always positive acute angles, so the measure of this angle is still 30 degrees. We just make it positive because it's more useful as a reference for us to think about it as 30, and it's always positive, the reference angle by definition. All right, so here we go. Cotangent of 150 degrees is almost the same thing as cotangent of 30 degrees. This should be negative, sorry. Now, for cotangent, there's a couple things that this makes us think about. Cotangent 30, should think about our 30, 60, 90 triangle. So 30, 60, 90, 1, 2, square root of 3. And let's see, going back to 30. Oh, cotangent. Cotangent is also the flip of tangent. So let's flip tangent. So tangent of 30, that's opposite divided by adjacent, so 1 over root 3. So cotangent is going to be the flip of this. Root 3 over 1. But then because we're in the fourth quadrant, let's just do an all students take calculus tangent should be positive, and it is. So just to emphasize that, I'll put a positive there, but it still is positive, which means cotangent is positive. Whoa, what's that? I've never seen that before. Cotangent is positive, the magnifying glass, that's what I clicked, okay. So cotangent of negative 150 degrees is equal to positive root 3 over 1, which is just root 3. All right, so to get the hang of this, there are 3 practice problems. They should be numbered 1, 2, and 3. Sorry about that, guys. Let's take a look at please pause here and do this part of the lesson. Let's take a look at the next part. So for the lesson here, we're going to do the last part with degrees, and then we're going to finally figure out what radians are in the next lesson. So coming soon, but not now. Write the 3 coordinate plane formulas for the trig functions sine theta, cosine theta, and tangent theta. So the 3 coordinate plane formulas are sine of theta is equal to y over r. Cosine theta is x over r. Tangent of theta is y over x. All right, these are all going to be the angles that we don't know how to find yet. So let theta equal 0 degrees. So this is a weird angle. It's not really part of a right triangle, and it's not like our usual coordinate plane picture, because 0 degrees is like the x-axis only. So let's see if we can figure out what each one of these is going to be. So these are the 4 weird cases that we're going to do in the next 4 problems. So for problem 2, let theta equal 0 degrees. Determine the sine of 0 degrees. Okay, well, we want a sketch of the picture here. So for 0 degrees, we go out some distance, and then we don't rotate at all. So this would be, we go out a distance r. So what are the coordinates of this point if we go out a distance r? And the reason why we're looking for the coordinates is all of our formulas have the x and y coordinates. Well, because we're going out this distance in the positive x direction, it looks like the x coordinate is going to be, we go r units out here, and then because we're on the x-axis, we go 0 units in the y direction, 0 units up or down. So it looks like we have our r value, we've got x, and we've got y. Okay, so sine of 0 degrees is going to be equal to y over r, which is equal to y over r. 0 over r, which is 0. Cosine of 0 degrees is equal to x over r, which is r for the x coordinate over r. R divided by r is 1. Tangent of 0 degrees is equal to y over x, which is 0. Oh, sorry, I should write that down. Y over x, which is 0 over r, which is 0. All right, so you guys are actually going to do problems 3 and 4, but we'll do problem 5 as one more example so you can go back. And I want to keep them in this order because it makes sense, 0, 90, 180, 270. So sorry about jumping around, but I think this makes a lot of sense. So for this one, let theta equal 270 degrees. We draw a green angle theta. This is 270 degrees. Oh man, this is a tough one. There is no reference angle that's going to help here because there's no positive acute angle with the terminal side. So the best we can do is we can say, no matter how far out we go r, we can actually figure out the coordinates because we're solely going in the y direction. So because we're only going in the y direction, the coordinates of this point will be we went 0 in the x direction, and then we went down r units, so we went negative r units in the y direction. So we actually know our r value, an x value, and a y value. All right, so let's write these down. Sine of 270 degrees is equal to y over r as always, so y over r, negative r over r this time. R divided by r is negative, so this makes it -1. Cosine of 270 degrees is equal to x over r, so that's 0 over r, which is 0. And then cosine of tangent of 270 degrees is equal to y over x, which is anything divided by 0, we learned in unit 6, I think, is undefined. So we have that. All right, guys. So once you're done doing these 4 problems, you're going to be able to get checkpoint 4, which is to fill out this full chart here. So the way you're going to fill out this chart as an example is sine of 0. You just go up here, sine of 0 was 0. Cosine of 0 is 1. Tangent of 0 was 0. So we put 0, 1, and 0 for that row. For this row here, sine 270, cosine 270, and tangent 270, we plug into the table down here. And you guys will be able to fill in these 2 rows together. If you want to check your answers, you can put a calculator in degree mode and compute these things, and it should give you the exact answers that you would have found from these practice problems. So I hope you guys found this helpful, and I'll see you in class on... Or I won't see you in class. Sorry, I always say that. We'll make another video for next week, guys. Have a good weekend, and stay safe.